As a final example, and this really does go beyond what you'd be expected to know, consider x cubed minus 2x squared plus a half equals 0. This is an equation we've met before. One possible rearrangement of this is x is the cube root of 2x squared minus 0.5. We get the iteration formula xn plus 1 is the cube root of 2 times xn squared, take away 0.5. On the graph, we can see y equals x, the green line, and y equals g of x, where g of x is this function here. We can see three roots, points where the graphs cross. Of course, these roots are the same as the roots of our original equation. We've worked with this equation before, and we know that we have one root in the interval minus 1 to 0, one root between 0 and 1, and one root between 1 and 2. On the graph we can see that near this root the blue curve is very steep, as it is here. Here though it is shallow, the gradient is less than 1. So this rearrangement might be expected to find this root, but not either of these two. What we're going to do is start the iteration near this root and see what happens. So we're going to start the iteration at 0.45. If we evaluate the curve at 0.45, immediately we can see it moves away from this root. We go across to y equals x, and we land almost exactly at the other root. However, what you'll see happen over the next few iterations is that we start to cobweb out from that root. It won't find this root because of the gradient. So even though we started near this root and landed almost exactly on this one, we can't find either of those two roots. What happens next is interesting. The curve goes across here, and we begin to see a staircase success towards the third root, the one we predicted that this arrangement would find. This is very complex behavior, and you're not expected to know this sort of detail. You should know, however, that some arrangements will tend to find a particular root. Other arrangements will find different roots. Yet further arrangements may not find any of the roots at all, and you'll see either a cobweb failure or a staircase failure from these arrangements. What is true, however, is that it's the problems with this particular method that make it so interesting to study. It's not a good method for a numerical solution to a root. First of all, you have the problem of which arrangement to use. We've seen that there's lots and lots of possible arrangements. Then we don't know until we actually start iterating what these particular arrangements will do. Will they find the root we're after, another root, or will they fail altogether? It's difficult to predict at the outset, and that means a lot of work could be wasted. Because of all of this, in the exam, you'll usually be guided towards a particular arrangement and a given number of iterations. But don't let that disguise to you the fact that this is a very interesting area of study. Maths in the real world is done largely by using numerical techniques. The real equations that come from things like physics and economics can't be solved algebraically in general, so usually a numerical technique is applied.